For this video, I'm going to be walking through the questions on the study guide. This is for you to use to either reference if your child is stuck on a problem or just to check their work. You should be able to fast forward or rewind or whatever you need to do. So let's get started. For the first one, first let me go over a few things. The focus means the skill that they are trying to practice. So for every set of problems, they'll have a focus. For this one, it is I can represent decimal multiplication problems using concrete models. So visual representation. Directions are to represent the problem in the specified ways. So first, we're always going to do the equation. So 1.7 times 3.2. They could also treat them as whole numbers and then add the decimals after. 7 times 2 is 14. 1 times 2 is 2, plus 1 is 3. We add our placeholder 0. 7 times 3 is 21. 1 times 3 is 3, plus 2 is 5. And then we add them up. Now we have to decide where the decimal point goes. In our two factors, we have 2 decimal points in all. And in all, we have 2 digits that come after the decimal. Decimal point, 1 digit. Decimal point, second digit. So in our answer, we should have 2 digits after the decimal point. So our final answer is 5 44/100. Now, though, they're tasked to represent that with concrete models. So with our area model, we're going to decompose each factor. And what I mean by that is we're going to go 1's place, 1 plus that next place, 7/10. We're going to do the same thing here. 3 plus 2/10. This is called an area model because essentially what you're doing is finding the area of each rectangle. 3 times 1 equals 3. 3 times 7/10 equals 2 1/10. We know that makes sense because when you multiply by a number less than 1, like 7/10, it'll be less than the first factor, so 3. 1 times 2/10 equals 2/10. And then 2/10 times 7/10. Again, since we're multiplying by less than 1, our answer should be lower than 2/10. 14/100. Next thing that we do is we add all of those together. So we're going to do 3.00, and I'm adding these to make sure my decimal points will be aligned. 2.10, 0.20, and then 0.14. 4, 4, 5. Great. I know it checks out because that was my original answer, my equation. The decimal grid, it can also be called an array, can be a little bit tricky. So first, what I have them do is I kind of outline the array. So for 1 7/10, I'm going to decompose just like I did up here. So we're going to have 1. That's supposed to be a straight line. And then we're going to have 1/10, 2/10, 3/10, 4/10, 5, 6, 7/10. Then I should have done that the other way. Sorry, y'all. Okay, so it's going to be 1, 1, 2, 3, 4, 5, 6, 7. And this is going to be 1, 2, 3 wholes, and 2/10. And what this does, I'm going to switch to a pencil, is it gives us a kind of outline of the array. So I know that we're going to shade in this amount. The answer will be how much space is taken up in the grid, kind of like an area model. Area is finding the amount of space in an object. An array is just a more exact way to do that with the area model. So now I count. I have 1 hole, 2 holes, 3 holes. 3 1/10, 2/10. Now I'm going to go horizontally. 3 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 4. 4 holes. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 5 holes. 1/10, 2/10, 3/10, 4/10. Oh wait, it was 3/10. Okay. So right now I have 5 and 3/10. I'm hoping that I can get 1400ths out of this to make my 5 and 3/10 plus 1400ths, which would give me 5 and 4400ths. 5 and 3100ths, 200ths, 300ths, 400ths, 500ths, 600ths, 700 hundredths, 800ths, 900ths, 5 and 400ths. Sorry, 5 and 4000ths. 5 and 41, 42, 43, 44. The reason I count these as hundredths instead of tenths is because it doesn't take up an entire row or column. So instead of counting a row out of 10 rows or a column out of 10 columns, I'm counting one square out of 100 squares. So when I add them all together, I get, again, my 5 and 44 hundredths. Okay. So these area model and the decimal grid are the concrete models that they'll be asked to use. Our next question, they're doing the same thing. 7/10 times 4/10. 7 times 4 is 28. One decimal point, 2 decimal points, 1 digit, 2 digits in all after the decimal. So our answer is going to be 2800ths. For an area model, you're finding the area of the entire rectangle. For our decimal grid, this looks a little bit different. So what I'm going to do is I'm going to represent 7/10 either vertically or horizontally first. So 7/10 for this, I know that there are 10 rows or columns, so that means that one row or column would equal 1/10 or 1 out of 10. So you can do 1, 2, 3, 4, 5, 6, 7. Then, so I should have 3 left, and I do. Then the other direction, I'm going to show 4/10. 1, 2, 3, 4. So what our answer is going to be is the overlapping, 1, 2, 3, 4, 5, 6, 7, is the overlapping parts. And the reason that's our answer is because we can also think of 4/10 times 7/10 as, or the opposite, 7/10 of 4/10, 4/10 of 7/10. So we're looking for that spot where it encompasses both. And what we'll find is that when we count each individual square, because we don't have a full row or a full column, is that we have 28 squares out of 100, 2800ths. So one takeaway that they should know is that when you're multiplying a decimal by a decimal, less than 1, we can think of it as of this amount. It's always going to be smaller than that decimal. Okay, I'm going to do one of these because both are pretty similar. So we're finding 3 and 6/10 divided by 1 and 2/10. So they're 1, 2 divided by 3.6. We don't want this number to be a decimal, so I'm going to make it a whole number by moving the decimal point over to the right once. I'm going to do the same thing inside. So really what I'm asking is 36 divided by 12. 12 goes into 36 3 times because 3 times 12 is 36. So our answer is going to be 3. For base 10 blocks, we're showing the result. So we're showing 3 groups that have what we divided by, 1 and 2/10. So in all, we have 3 6/10 divided by 1 2/10, which makes 3 equal groups. With our number line, we're going to start at 0, and we're going to end at 3 6/10. They do not have to label the exact points on the number line. So what we're going to show is that division can also be represented as repeated subtraction. So what I'm basically doing is subtracting 1 2/10 from 3 6/10 until I get to 0. So 3 6/10 minus 1 2/10 equals 2 4/10. 2 4/10 minus 1 2/10 equals 1 2/10. 1 2/10 minus 1 2/10 equals 0. And we see that we jumped 1, 2, 3 times, as is our answer. 3 groups of 1 2/10. This one is similar. It's just a higher number. Sorry, there's a little interruption. Okay. That's similar. So our next focus is, I can solve decimal multiplication and division problems and explain why my answer is reasonable. So they will estimate, then they'll solve the following problem, and then they'll justify their answer. Justify just means explain why it makes sense, as indicated in the focus. So Theo's desk is 17 3/10 inches tall. Ishan's desk is 0.3 inches of Theo's. So that of should be a hint that we're talking about multiplication here. So to find 3/10 of Theo's, we multiply 17 and 0.3 times 0.3. Now for my estimate, I can change this to 17, and I can change this to, let's say, 1. You don't want to use 0. So I could say that 17 times 1 equals 17. However, I know that when I multiply by a number less than 1, my answer is going to be less than that number. So I actually know that my answer will probably be less than 17. Now I'm going to go to my solution. 3 times 3 is 9. 7 times 3 is 21. 1 times 3 is 3 plus 2 is 5. Decimal digit, 2 digits in all. So my answer is 5 and 1900ths. Okay. So for my justification, what I want them to mention is that knowledge of, I know that my answer is going to be 17, less than 17, but not too much less, right? Like it's 12 away, that's fine. So this makes sense, knowing the knowledge of, okay, it's going to be less than 17, but it's not going to be 519 thousandths. That would be too small from our estimate. It's not going to be 51 and 9/10. That would be too big according to our estimate. So 5 and 1900ths makes sense because it's less than 17, but the decimal point is placed correctly, as long as they can justify why it makes sense. Okay, so magnitude, how far away it was from our original estimate. Precise language, specifically what did they know and then do. And then, using their estimate, which goes along with magnitude, why the decimal point where it is makes sense. Same things with these, but I want to talk about this one. Winter is going to the grocery store with $1.92 to buy grapes. A pound of grapes is 48 cents. How many pounds will Winter be able to buy? What they should include in their justification and the knowledge they should use in their estimate is that when we divide a number by a digit or a decimal less than 1, like 48 cents, then our answer is going to be more than our original number. So our answer should be more than 1 and 92 cents. Okay. So they should use that in their estimate. They should also talk about that in their justification. What I will go over, though, just thinking of it, is the answer just so they can check it. So this is a multiplication problem. We're finding the area, width times height. 1 times 9 is 9, plus 7 is 16, 10, 0. 8 times 2 is 16. 1 times 2 is 2 is 3, 2. And now I'm going to double check my math. It should be 34 and 22 hundredths, but let's make sure using my calculator. Good. Okay. And then for this one, we're going to do 48 into 192. Okay. So I know that 15 to 200 is about 4, so I'm going to check that. See, 19, great. So it goes into it 4 equal times. So this number is more than 192, so that is why so my answer makes sense, because I knew it would be bigger than 192 based on the fact I was dividing by a number less than 1. That should be in their justification. This is going to be similar. Focus, I can explain how numbers change when they are multiplied and divided by decimals greater than, equal to, or less than 1. So then they're tasked, without solving, determine which number is greater. Justify your answer. So we have 1 in 938 thousandths, and then we have 1 in 938 thousandths times 2 tenths. They should use the knowledge that when you multiply by a number less than 1, it's going to be less than this factor. So I know that this is greater because multiplying by 2 tenths will give me a number less than 1 in 938 thousandths. The explanation would sound like, I know that when I multiply a number by a number less than 1, my answer will be smaller than the first factor. 1 in 938 thousandths is greater because multiplying by 2 tenths will give me a number less than 1 in 938 thousandths. So they should mention the rule, and then they should mention the specifics of the problem. So general rule, specifics of the problem. On the other hand, when I multiply it by a number greater than 1, my answer will be bigger than that original factor. So I know that this will be more because when I multiply by 2 times 3, 2.3, my answer will be greater than 84 and 14 hundredths. When I divide by a number less than 1, my answer will be bigger than my original factor. When I divide by a number greater than 1, my answer will be smaller than my original factor. These were the types of problems they were practicing last night. So I can use my knowledge of multiplicative comparison, so comparing different quantities, to find how many times more. Solve the following problems. So my job is 7 and 8/10 miles from my house. My husband's job is 3 and 5/10 times farther away. How far away from our house is my husband's job? So I know based on the fact that it's 3.5 times farther away, but I don't have that second quantity yet, that I'm multiplying 7.8 and 3.5 to get to how far away my husband's job is. So to estimate, I'm going to say 8 times, let's say 4, equals 32. So my husband's job should be about 32 miles away. And now we find the actual solution. 40, 7 times 5 is 35, 39, 0. 8 times 4 is 20, 8 times 3 is 24. 7 times 3 is 21, plus 2. Okay. 3, 7, 2. Good. It's pretty close. 27 and 3.3 miles away. In these answers, they should, I forgot to mention the other one, they should mention the unit as well. So the quantity plus the unit. Reese's bunny is 2.5 pounds. Ophelia's guinea pig is 9/10 of That's a good hint that we're using multiplication of the bunny's weight. How much does the guinea pig weigh? So I can say, we can use 2 or 3 here, doesn't matter. 3, I'm going to change 0.9 to 1, so 3. But I know that when I'm multiplying a number by a decimal less than 1, it's going to be smaller than this. So really, I know that my answer will be a tiny bit smaller than 2.5. Just a tiny bit, because 9/10 is almost all of it. So then I figure out 0.9. 2 times 9 is 18, plus 4 is 22. So the guinea pig weighs 2 and 2/25 pounds. On average, Jamera reads 14.4 books per month. Her uncle reads 4 and 8/10 books per month. How many times more books does Jamera read than her uncle? Okay, so for this one, we're finding how many times more. Usually when I know both quantities, so the amount of books for each person, then I'm dividing to find how many times more. That's the information we're missing. So I'm going to change this to, let's see what's workable for 4. Let's say 16. I could even do, let's try this, 15 divided by 5. So I know that Jamera probably reads about 3 times more, but let's check it to make sure. So 4.8, 14.4, 48, 144. So I know that 50 goes into 150 about 3 times, so I'm going to check. Great. 3 times 4.8, or 48, excuse me, is 144. So Jamera reads 3 times more, and that is spot on with my estimate. This is the whole study guide. If you have any questions, please let me know. Just send me a quick email tonight and I'll try to get to it as quick as possible, especially with the ones that I did not go over. But hopefully you're able to solve it with a little bit of the help that was provided on the video. Just send me an email, let me know. Their milestone will be Thursday and Friday.